This is the second tutorial on friction, and we're going to look at friction on an inclined plane. So previously what we had was friction on a flat surface. This time we're going to incline that plane, and last time we said that we have three things at play. Basically, we've got a coefficient of friction, which is how friction near surface is. We have a normal reaction, which is the reaction which is perpendicular to that surface, and we have a frictional force, which is a force which is parallel to the surface, which we need to overcome to move an object. So what we're going to look at here is, once we start inclining a plane at 20 degrees, the important part is that we know that the normal reaction is a reaction which is perpendicular to the surface, which is what we said last time. And so in this example, the weight force is not equal to the normal reaction, and that's the most important thing that we need to remember for this point. What we do find, though, is that the weight force gets transferred into two forces, one coming down and into the slope, so one going into the surface, and then a component of weight going down the slope or parallel to the slope. And so you ultimately, this force over here, which can be replicated over there, creates a force triangle or a right angle triangle of the weight down the slope and the weight into the slope. And without going through all the trigonometry and everything else that you need to look at, just trust me, this angle between the weight into the slope and the actual weight component itself is always going to be equal to the angle of inclination. Meaning, as we incline the slope, less and less weight goes into the slope and more weight goes down the slope. And that angle will always be the same as the angle of inclination. So you can just remember that off the top of your head. There is a quick proof I could show you, but I'm not going to waste your time doing that now. So if we know that, what we can then see is, using sine, this being the hypotenuse of 1,000, and cos, this being the adjacent of that triangle, we can see that 1,000 sine of 20 degrees is equal to the weight going down the slope and 1,000 cos of 20 degrees is the weight going into the slope. So let's just quickly punch those out. 1,000 sine of 20. So the weight going down the slope is 342 newtons, and 1,000 cos of 20. The weight going into the slope is 939.6 newtons. So we've very quickly worked out how much weight goes into the slope and how much weight's going down the slope once we start inclining this. Alright. Now let's look at the concept of us pulling this box P up the slope. Well, for us to be able to move this box up the slope, the first thing that we need to do is we need to overcome friction. So we said that friction is governed by how much weight is going into the slope, or the reaction to the normal, and a coefficient of friction. So when we have a box like this, if it wasn't a flat surface, we would need to overcome a frictional force, FF. And it's exactly the same on a slope. We still need to overcome friction to get the box going up the slope. So to move the box up the slope, we need to overcome some friction, plus we need to overcome the amount of weight going down. I'm going to call it the down weight. So we need to overcome the frictional force and the amount of weight going down the slope. So we can't just start doing throwing out our coefficient of friction or our normal reactions equal to our weight. Let's start looking at this. The normal reaction is actually this force over here, which is the amount of force going into the slope, because it's reacting to that. And so our frictional force, let's just do it over here, frictional force is equal to mu times Rn, which is 0.5 in this case, I've just given it to you, times our normal reaction, and our normal reaction is this 939.6, which comes out to be 469.8 newtons, half of that. So that's the frictional force that we need to overcome in order to get this box moving. We also know that 342 newtons of this weight is acting down the slope. So P needs to overcome both of that and that. So it's equal to 469.8 plus 342. And that overall, if I add the 469.8 plus the 342, I get 811.8 newtons, which is the amount of force that we need to pull and overcome friction and the weight going down the slope. So you can see how it's slightly more complex than just the basic flat system, because we need to remember that our normal reaction in an incline is not equal to the weight of the object. I hope you found this useful.